thickness of 10 millimeters. And it's a plate of W250 by 80. Okay. So we are given that stress yield is equal to 345 times 10 to the power 6 Pascal. And we are also given that Young's modulus is equal to 200 times 10 to the power 9 Pascal. Okay, we're given that. So we have to follow the allowable stress design. Okay, so the allowable stress design. Okay, so this is where, okay, we are going into summary sheet again. Okay, so we are going to look at the allowable okay, we are going to look at the allowable stress design. So the allowable stress design, okay. So again, I will provide you the formula sheet. Is when we use this when we have our stress, critical stress is equal to what? Is equal to 0.658, right? Stress U divided by stress E, right? And then you have stress U. Now we will use this is if your L over R is less than 4.71, right? Square root of E over stress Y. Okay. And the other set of formula you use where stress critical is equal to 0.877. I'm looking at the formula sheet now, by the way, that is provided in the term test, okay? It's equal to stress E. And you use this when L/R ratio is greater than 4.71 E divided by stress U. Okay. And then this one, we have to apply that stress E is equal to pi squared E over L over R squared. And there's another formula that for the allowable stress design you have to apply is that the stress allowable, okay, is equal to stress critical divided by 1.67. Okay. So I think the most important thing is these two condition over here, okay, where I'm going to highlight them. Okay, so these two conditions are critical. When to use what formula, okay? So after knowing all this, right? So now we realize that, okay, we need to find some values now, okay? So we are going to find the structure which is W250 by 80. Okay, so I'm going to get information. I'm going through my textbook to get the information, okay, which I've uploaded for you to download. So again, I will provide tables like this, okay, for you. Okay, so this is the table. Okay, so this is the table where we provide. The best thing to do if you get a table like this, you follow the transformation as the figure, that this is your x and this is your y. Okay, so we know that W250, so we know that IXX. Okay, so based on W250, right, by 80, right, IXX is equal to 126 times 10 to the power 6 millimeter to the power 4. Okay, so we know that we have two plates welded, right? So we want to find the IXX total. Now, before we go on, okay, we also know what is our IYY. IYY is equal to 42.9 times 10 to the power 6 millimeter 4. Okay. So from here, if we were to look at this, right, like looking at the second moment of area, we know that buckling, right, buckling will occur in IYY. We know that, right? But we cannot take this value by phase, or we cannot determine yet, because there is this two extra plate welded. Okay, there's a plate welded here and the plate welded. We have to determine the total IXX or the total what? IYY. Okay. So as engineers, we have to know the absolute value. You cannot say, Eugene, isn't it obvious it's going to be IYY? Okay. We don't know. Okay. We have to prove based on numbers. Okay. So from here, we are going to determine IXX total. So this is equal to 126 times 10 to the power 6. All right. So this is your what? This is your XX. Right. So this is your width. And over here, this is your what? This is your depth. Right. So IXX formula, maybe we forget. So you go back here, you provide on your formula sheet. So I is equal to width depth cube over 12 plus by area global centroid minus by individual centroid squared. Okay, this is, if you don't remember, just write that down. Okay, so from here plus, so for this twice. Okay, so you have your width. Okay, so I don't know what's my width. My width is my BF. Okay, so BF. So BF is 0.254 or 254. So width, right? We know our depth plus by the cross-sectional area or by the area. And then Y bar is equal to what? So it's D divided by 2, 257 divided by 2 minus by the thickness divided by 2 squared. Okay. So you do this. So you get 126 times 10 to the power 6 plus by 254 times by 10 power 3 divided by 12 plus by 254 times 10 times by bracket 257 divided by 2 minus 10 divided by 2 close bracket squared. So this is equal to twice of 38.762 times 10 to the power 6. I will do it again. 254 times 10 to the power 3 divided by 12 plus 254 times 10 times by 257 divided by 2 minus 10 divided by 2 close bracket squared. 38.762 times 2 plus by 126 power of 6 is equal to 203.524 times 10 to the power 6 millimeter 4, or 203.524 times 10 to the power minus 6 meter 4. Okay, so we got that. Then we go for, did I do it? Somehow the book is different. Let me see what is different. The width is 254. The depth is 10. The width is 254. The depth is 10. And then 257 divided by 2 minus 10 divided by 2, 254, 10. I get 203. The book is 216. Let me, maybe I press my calculator, or hold on. Let me check the number. Okay, the numbers are the numbers are different because the right value is 254. They use 255. The right value is 257. Okay, so their numbers. Hold on, I think I know where I make the mistake over here. So the centroid, yeah, I make a mistake. So what they given to here to here, I make a mistake, my bad. So here to here is equal to 257 divided by 2. So from here to halfway, this is 10 divided by 2, and it's a plus. My bad, I make a mistake. So I'll do it again. It's not minus. I thought it's inside, but it's not. I found that mistake. So 257 or 257 divided by 2 plus by 10 divided by 2 squared times by 254 times 10 plus by 254 times 10 power 3 divided by 12. So I get 45.29 times 10 to the power 6. Let me do it again. 254 times 10 power 3 divided by 12 plus 254 times 10 times by 257 divided by 2 plus by 10 divided by 2 close bracket squared 45.29. Okay, 126 power 6 plus 2 times 45.29 power 6. So the answer is 216.58 times 10 to the power 6 millimeter to the power 4. Okay, or 216.58 times 10 to the power minus 6 meter to the power 4. Okay, so that is our I total for the IXX. Okay, so next we go for IYY total. So it is equal to 42.9 times 10 to the power 6 plus. So IYY is more straightforward, so I will use a different color. This is YY. So this will be our width. This direction will be our depth. Okay. So for this case, it's more straightforward because we only need to do BD keyword 12. The AD squared, the D is equal to 0, or the distance from the centroid, because all of them share the same centroid, that's why it's equal to 0. So the width is 10. And then this is 254 power 3 divided by 12. Okay, so that's IYY. So 10, so this will be equal to 42.9 times 10 to the power 6 plus by 254 power 3 divided by 12 times 10 times 2 is equal to 27